Hello everyone, today we are going to present you a video assessment on what is differentiation and how to calculate derivative for our calculus assessment mat183 course. So let me introduce our group member first. Our group member include 4 person, which is me, Wan Muhammad Arif Aikal bin Wan Hasnan, Izzat Hakimi bin Ruzain, Amin Akif bin Muhammad Arif, and our group leader Aidil Farhan bin Badrul Hisham. And our topic is application of differentiation. But before that, what is differentiation?
Differentiation is a process of calculating a function which is an essential step in the calculus concept of differentiation. At the same time, the derivative measures a function progress as an input. Variables values differ from one another. It offers details on a function rates of change at any specific moment.
Why and when do we use it?
Differentiation allows us to measure the rate at which a function is changing at any given point. By finding the derivative of a function, we can determine how quickly the function is increasing or decreasing. Okay, we take an example, finding a velocity of a car. Calculating a curve in a graph to calculate the profit and the loss in the business using graph. And then many else. Problem statement. Ideal walks at rate of 3.5 meter per second away from the lamppost as shown in the picture below. The height of lamppost and Ideal are 12 meter and 1.7 meter respectively. Find the rate of change Ideal's shadow.
Wait, for your information, before you do a calculation of differentiation, there is something very important for you to know. Firstly, you need to recognize a variable that will have a constant rate. Then, you have to determine which variable have a manipulative rate in it. After that, you will apply the derivative rules if any calculation needed. And lastly, always respect to time if you are having a hard time.
From the picture given above, we can see Ideal is walking away from the lamp post. Based on question, it is stated that Ideal's walk speed is at 3.5 meter per second. Now, we can draw the line. We can draw a line on the picture given for our references. Top one, height, and the length. Now you can see a perfect isosceles shaped triangle. Then we draw another blank triangle with some value that given in the question, which will look like this. The height of this triangle are 12. This is Ideal, and the height of Ideal is 1.7 meter, and Ideal's walk speed is at 3.5 meter per second. Then this is Ideal's shadow. Now we draw another one, but here we replace Ideal with a line for representing it as another triangle, here and here. Now we break these two triangles into two. The smaller one, we call it as a triangle. Here we can use trigonometric formula, which is tan. Tan is equal to opposite over adjacent. This is theta, and the opposite of theta is 1.7, and the adjacent are x. So tan theta is equal to 1.7 over x. Next one, the bigger one, we call it as B triangle. We also use the same trigonometric formula, which is tan, and our opposite here are 12 and our adjacent are x plus y. So tan theta are going to be 12 over x plus y. Now, after we have both equation, we can do simultaneous equation, and it will look like this: 1.7 over x equal to 12 over x plus y. Then here we can do cross multiplication. Here 1.7 times with x plus y and 12 times with x, and it will look like this: 1.7 times x plus y equal to 12x. 1.7 here can be expanded to x and y, and it should look like this: 1.7x plus 1.7y equal to 12x. We only need one variable of x, so we don't need this one. We can simply just remove this x variable by subtracting the number itself. 1.7 subtract by 1.7x. But may I remind you, simultaneous equation, if you do on the left side, the right side will be affected as well. So the 12x are going to be subtracted by 1.7x as well. After we then subtract it, we have our d over dt, which is 1.7 y equal to 10.3x. Now the question: at what rate is the length of the shadow increasing when ideal is keep walking at the same rate of speed? Here we have our d over dt. Both of these are respectable to time. Now we simply do it dy over dt. So it will look like this: 1.7 dy over dt equal to 10.3 dx over dt. Both of these equations are respectable to time, which is dt. Now we have to find the dy and the dt and the dx. Now we have to find the dy over dt and dx over dt. So what is dy? Dy are the speed of ideal's walk. So as we can look here, this is y. Y is 3.5 meter per second, and the dy are respectable to time. So our dy over dt is going to be 3.5 meter per second. So we can simply substitute it into the equation, which is 1.7 times 3.5 equal to 10.3 dx over dt. Then after we done with the multiplication, we have 5.95 equal 10.3 dx over dt. Now we don't need this 10.3 because we have to find dx over dt, which is the shadow of ideal. So we need to remove this by simply dividing it by the number itself, which is divided by 10 over 3, and the left side as well, divided by 10.3. So after the division has been completed, we have our own dx over dt, which is equal to 0.58 meter per second. Hence, every time ideals walks at a rate of 0.58 meter per second, the shadow length will be increased.
Last but not least, for the conclusion of using differentiation. Differentiation plays a crucial role in optimization problems, where we seek to find the rate of changing either increasing or decreasing, and for finding maxima and minima values of a functions. By finding critical points and using the first and second derivative test, we can identify optimal solutions and make informed decisions in areas like engineering, economics, and finance. Mastering on using derivatives in daily use will make a day more easier than we thought it will be. Thank you for watching.